Hey, good morning, guys. Have to be out today, so I'm going to leave this video for you to take notes on for another case for the law of sines. We didn't get a chance to do that yesterday, so give you the notes for this, and then you'll have a worksheet on it that the sub will give you, and just kind of work through that, and then we'll go over what we need to for tomorrow. The answer key will be up on the board, so you can check your answers as you're working through it. But I do have to give you several examples to get through to show you all three cases. So just to review a little bit, we have been talking about law of cosines and law of sines. We did have the side, and side angle side. We did that for the law of cosines. Remember, we're not really too much worried about the triangles and how they're identified, but if all the letters are different, that is a law of cosine problem. And then we did the law of sines problems where we had two letters that were in common. So that meant, like a capital A and a lowercase a, or capital B and lowercase b, that would be what you would be given to start with in the problem. All right, but we're going to look at a new case today, which is called side-side angle. Okay, now typically when you have two sides and an angle, that would fall under the law of cosines case. But with this type of problem, in this particular case, it actually falls under a law of sines problem. And the reason is that although you have two sides and an angle, you're going to be given two letters that are in common. And remember, if you have two letters that are in common, then it is a law of sines problem. So the only way you can use law of cosines is they all have to be different. So, but the tricky part is this. If you do have this case, then we have to do the problem a little bit different than what we've been doing, because if you have side-side angle, which means two sides and one angle, then this is all of your possibilities for your solutions now. So you could have zero triangles, which means you'd get no solution. You wouldn't work that problem any different than what we've been doing. You could have one triangle, which that's the same type problems that we've been working, but then this new case is going to come into play, which is two triangles. And so what happens is when we have two sides and an angle as the given information, two sides and an angle, and two of the letters are in common, which means we cannot use the law of cosines, we have to use the law of sines, then this is what's going to happen. We're going to have to check for 0, 1, or 2 triangles. And so I'm going to give you an example of each one of those and show you how it works. Now, if you use the law of cosines to start a problem, you do not have to check for a second triangle. That is one triangle, period. But if you use the law of sines to start a problem and you have two sides and one angle, okay, then you're going to have to check for a second triangle. Now, the cases that we looked at yesterday, two angles, both of those have two angles, you don't have to check for a second triangle. It's only this case right here. Okay, so we're only looking at, if you got the two sides scenario here. So let's take a look at an example, and if you need the sub to pause the video or anything as we're going through it, then you can certainly do that. Okay, and then we'll give you time to copy it down and whatnot. All right. So example one, and also this video is on the blog too, so you can always go back and look at stuff and fill it in on the blog. All right. So solve the triangle. Capital A is 85, lowercase a is 15, lowercase b is 25. So when I look at this problem, I know that I have two sides and an angle. Okay. But I have a capital A and a lowercase a. So since I have in common, that's law of sines, and since it's two sides and one angle, that means I'm going to have to check for a second possible triangle. So now on your worksheet and your answers, you're going to have two spaces for triangles. That doesn't mean that there is two triangles, it just means there could be. So you'll have an answer space over here for a second possible triangle. So when we look at this, let's just solve it like we've been doing last couple of days. A is 85, lowercase a is 15, b is 25. That's given information. So I have to solve for capital B first because that is my only option. So I'm going to set up my proportion. Sine of 85 over 15, so that's sine of A over A equals the sine of capital B over 25. And if you remember, we solved these by cross multiplying. So 25 sine of 85 equals 15 sine of B. And if we divide both sides by 15, okay, we come up with, let's see, and remember, I'll just refresh you on how to do this in the calculator. 25 sine 85 and then divided by sine 15, or by 15, excuse me, not sine 15, just divided by 15, all right? And that gives me this 1.66 number, okay? And then, so we've got 1.66 equals the sine of b, and if you remember the way we solved these, to get rid of sine, we did sine inverse. Hopefully you remember that from the last unit. And when we would do sine inverse here, sine inverse of 1.66, we get domain error on our calculator. So what that means is here, okay, we got an error message, so that means no solution. And whenever you get no solution, what that means is we have no triangle. And so if we don't even have a first triangle, we definitely don't have a second triangle. So the answer to this problem is just we have no triangle. Okay, we can't even fill in the answers here because the first triangle doesn't exist. So the second one certainly does not exist. All right, so that's what a no triangle problem will look like. Okay? All right, so let's take a look at one that will work here. So let's example 2 here. Okay, so again, solving the triangle, capital A is 42, lowercase a is 22, lowercase b is 12. So as I look at this, when I look at this, I got capital A and lowercase a. That tells me immediately that this is law of sines. Okay, this is a law of sines problem. But I'm giving two sides and an angle, which means I'm going to have to check for a second triangle. So here again, we got to solve for b here. This would be my first triangle right here. Over here, this would be our second possible triangle. Okay, so I've got to solve for b. So again, we're just going to do the same thing. Sine of 42, which is sine of a over lowercase a, equals sine of b over 12. And same thing, cross multiply here. So 12 sine of 42 equals 22 sine of b divided by 22. And so again, we take our calculator here and we go 12 sine 42 divided by 22, and we get 0.364 or 0.365. We can round it to that. All right, so I'm given 0.365 equals the sine of b. And again, we're going to do sine inverse here to solve it because they cancel over there. And if I do the sine inverse of 0.365, we get 21.4. I'll just round it to 21.4. Okay? So, I did get an answer this time. 21.4 is my capital B. So I'm going to write that in here, 21.4. Alright? Now, I'm going to solve this triangle just like I normally would. If I know two angles, I can get the third angle by simply taking 180 minus 42 minus 21.4. Okay? And that's going to give me 116.6. So I'll solve that, and now I can solve for lowercase c just like we've been doing. And I'm going to do that in just a minute. So I know I can get an answer here. But here's the key for these problems. Okay? I just found that b was 21.4. Right there. Okay? Alright? So up here, when I put 21.4 in for b, alright, this is what I'm going to use to check to see if there is a second triangle. So what I'm going to do is I'm going to come over here for my second set of answers, and I'm going to write down an answer for b right here. Now, here's the way you find this answer for b. You simply take 180 and we subtract the answer we just got for b of 21.4. Okay? Now when I do that, 180 minus 21.4, I get 158.6. Okay? So this b value right here is 158.6. Alright? Now, why are we using the 180? Well, it has to do with obtuse angles and why the second triangle would occur, and I can explain all that to you later. But we get 158.6. So now, to find c, we would do the same exact thing. We would take our 180, and we would subtract 42 and 158 58.6. That's what we would do here. Okay, so 180 minus 52 minus 1, or minus 42, sorry, 42 minus 158.6. And when we do that, we get negative 20.6. Okay, so that's what I just got for this answer, negative 20.6. Well, you can't have a negative angle measure. So since that came out to be not true, what that means is there is no second triangle. So all we have to do is finish solving for the first triangle here. So what I'm going to do is I'm just going to come back over here now and I'm going to solve for C. So I'm just going to do the same thing we did previously. Sine of 42 over 22 equals the sine of 116.6 over C. Cross multiply. C sine of 42 equals 22 sine 116.6. And we divide by the sine of 42. Now this is like what we were doing 2 days ago in our work. So when we type this into our calculator, we end up with C equal to 29.4. So I would put 29.4 there for C. Okay? So that's that. All right, so let's do one more here. I'm going to go through this one pretty quick. All right? Because it's just the same thing that we've been doing. Again, A, B, C, we got two letters that are the same here. We got two sides. We're going to have to use, our law of sines here. So I'm going to go sine 20.5 over 12 equals sine of B over 31. We go through the same scenario here that we've been doing on all these problems, and I'm just going to go ahead, rather than working it all out, I'm going to tell you that capital B comes out to be 64.8 degrees. So, as always, 64.8, so I know I've got one answer here. I subtract that, 180 minus 20.5 minus 64.8. Okay, that gives me 94.7. And then I can go and solve for C. Okay, just like we've been doing. Okay, so I'm going to let you solve for C. What I want to make sure is that we know how to find the second triangle here. All right, so what I would do here, the answer I just got for B, that's 64.8. I'm going to come over here and I'm going to say, okay, 180 minus 64.8. All right, and when I do that, 180 minus 64.8, okay, I get 115.2. Okay, so now if I take 180 and I subtract 20.5 and I subtract 115.2, I now get 44.3. Okay, I didn't get a negative number like I did on the previous example. So what that means is, yes, I do have a second triangle. So now what I have to do is I have to go back to the first triangle and I have to solve for C. Okay, and then I also have to solve for C in the second triangle over here, and I'm going to get two answers for this. So, in the first triangle here, we could just set this up again. Sine of 20.5 over 12 equals sine of 94.7 over C, and you'll solve that. And then we could come over here, and we would say, okay, sine of 20.5 over 12 equals the sine of 44.3 over C, and we would solve that for C. And that would get you your two answers there. Okay, so just to make sure we've got the answers down here, let's see, cross multiplying here, C sine 20.5 equals 12 sine of 94.7. So we're going to go 12 sine 94.7 divided by the sine of 20.5, and that gives me 34.2 for C here. All right, so we got that one, and then over here, we have the same thing here, 12 sine of 44.3, and so basically I'm going to take 12 sine 44.3, and we're going to divide that by the sine of 20.5, and we're going to get 23.9 for that answer. And that is law of sines, where you have two triangles. I hope you guys have a great day, and I will see you on Friday.